Creating pictorial views from orthographic views requires us to have a gridded paper we call isometric grid paper. That makes it very, very simple to create these views. Given the front, top, and right side views, we look at the adjacent areas, and we begin by identifying these areas with a letter. Okay, so we neatly letter. Remember, you've learned how to do some neat lettering. So you would letter each surface, each area. You would also begin laying out the maximum dimension or a box, creating a rectangular prism that would contain this shape based on the dimensions, using a piece of paper to transfer the dimensions. We analyze by looking at the surface, in this case A, and we see that A matches up with this edge. So we will assume that this edge is surface A. Yeah, we can do assumptions and assume things, then we have to prove them. We find the front surface of our box and begin laying out a grid point at a time. Maybe start out by making dots and then connecting lines between the dots and show where surface A is. So we try to address all the surfaces that are on the outside edges of the box or outside surfaces. Then we do the right side view the same way. Here's B. We project over, and we can see that B is an edge here. Total height, total height, total depth, total depth. So we will assume it's on the right side, this shape. We'll sketch that in. We then do the same thing for the top view. We look at C, that area. We find that it matches this edge and this edge. So we transfer the depth dimension and the width dimension and create that surface on our box. We then begin carving away and finding where the other surfaces are located at various depths or at various widths, kind of visually cutting into the object that we've sketched here. So we can see we got two grid points for D. D is here. It matches up with this edge. So I know the depth and I know the width. I already have the width identified. The depth then is drawn in along the grid points of the isometric grid. And we know it's 2 down. We start at that edge. And we begin sketching in a surface at a time. Finding normal surfaces is relatively easy to do. We follow this through. Here we're finding E. We sketch in E. Sketching in the height, and the depth is already shown to us. Here, we're in the process of locating F. F matches up with this edge, so that gives us the width and the height. So once you find 1 or 2 points of a surface, or an edge is already found from a mating edge, then it begins to, what I call, kind of fall in place. It can't really appear anywhere else. And so you begin to complete the cutaway of the object and apply the visible lines. Another example, normal surface pictorial. Step 1, if we're going to draw this object, block it in with all of our major dimensions, sketch the box that would contain it with our maximum dimensions. Then we modify the box looking at our top view and find what surfaces are touching the top, what surfaces are touching the front or facing the front, and what surfaces are touching the right side view or facing the right side view, and cut away by projecting into the box and counting the number of squares or grids to find the location of each surface. Next, we'll look at inclined surfaces.